Hello, grade 12s, and welcome to the math session. My name is Goodness Shoba, and today we will be focusing on the functions and graphs, but our main focus for today, for this lesson actually, will be on what? On linear and quadratic functions. Let's take a look at our lesson outcomes. By the end of the lesson, we should be able to sketch the linear and quadratic functions showing all the intercepts with the axis. And we must be able to do the graphical interpretation of both linear and quadratic functions. This is the main focus of this session. Okay? Now let's get into details now. What are we referring to when we say function? When we say function in maths, a function is defined as the relationship between values where each input value maps to one output value. So in order for an equation to be called a function, there can only be one y value for a particular x value. So it means, in simple terms, if our equation now has two or more y values for a particular x value, then that particular equation will no more be called a function, but it will be called what? A relation. Okay. Let's look at the functions we dealt with in grade 10. In grade 10, we dealt with we covered the concept of the linear functions, the quadratic function, and the exponential function together with the hyperbolic function. Hence, I said my focus here will be on linear and quadratic. So with the linear function, the standard form is y is equals to mx plus c, or f at x is equals to ax plus q. So whereby this a or m, parameter a or m, refers to what? Refers to the gradient of the function. So now, there are conditions to consider. If our gradient or our m is greater than 0 or positive, then it means we are going to get an increasing shape. Our graph will have an increasing shape. We'll be of this shape. We'll be facing towards the right-hand side. So if our gradient is less than 0 or negative, then it simply means we are going to get a decreasing function. Our graph will be moving from left to the right-hand side. The graph will be decreasing. Remember, when you look at the decreasing and increasing function, you need to look at the left-hand side from left. You read from left to the right-hand side. So if our gradient is equal to 0, then it means our linear graph will be parallel to the x-axis. And with m now, with m is undefined. In case m is undefined, then it means now our graph will be parallel to what? To the y-axis. So this is the standard form of a quadratic function we dealt with in grade 10. An exponential function, we have f at x is equal to a multiplied by b to the power x plus q, whereby b is greater than 0 and b should not be equal to 1. So the hyperbolic function has the standard form f at x is equal to a over x plus q. This was just a recap on our grade 10 functions. Okay? However, in grade 10, we only focused on two parameters only, parameter a and parameter q. Now let's take a look at the grade 11 functions. Now in grade 11 functions, we have the concept already of the quadratic function of this form. F at x is a into x plus p all squared plus q, or f at x is ax squared plus bx plus c, or f at x is a into x minus r1 multiplied by x minus r2. So your quadratic function can either be in this format or in this format or in this other particular format. Now with an exponential function, f at x is equal to a multiplied by b to the power x plus p plus q. Same applies to this, where the b is greater than 0 and b must not be equal to 1. The hyperbolic function is in the form of a over x plus p plus q, okay? So in grade 11, we had to deal with three parameters at the time. Parameter a, parameter p, and together with parameter q. So in simple terms, parameter q was introduced now in grade 11 content. And now let's take a look at the properties of a parabola function. Okay, how do you identify, or how can you identify a parabola function? So a parabola function should be of the form of what? Should be in this form, f at x is equal to a into x plus p all squared plus q. You can see that this is a parabola function, and the p refers to what? The x value of the turning point, and q refers to the y value of the turning point of our given parabola function. So if you are given your parabola function in this form, you must just know that, okay, my turning point, this p and q are representing what? The coordinates of the turning point of the given function. Sometimes your parabola function can be given in this form, ax squared plus bx plus c. So our c refers to the y-intercept of the graph or the function, and the b is responsible for the horizontal translation. So if you are given your parabola function in this standard form, in that format, so it means now for you to be able to determine the turning point, you can just use the equation x is equal to negative b over 2a to determine what the x-intercept of your turning point, so that you can just substitute it back to the given original function for you to get the corresponding y value. Or it can be given in that form, f at x is equal to a into x minus r1 into x minus r2. So now, r1 and r2 are the x-intercepts of the parabola function, okay? Now, if you are given your parabola function in this format, it means now for you to get what? The turning point of this, it can be easy, because these are the r1 and r2 are the x values of what? Are halfway. So we can say x value of the turning point is halfway between what? The intercepts. So since our x value of the turning point is halfway between the x-intercepts, so you can just determine, you can just say r1 plus r2, determine the midpoint or find the midpoint between r1 and r2. Then you can just substitute it back to the original, your answer back to the original, so that you can get the corresponding y value. So now let's take a look at the shape now. So the shape of our parabola function will depend on the parameter a now. So if your parameter a is greater than 0 or is positive, so it means your shape will be concaving upwards, okay? So if your a is less than 0, then it means now your graph will have to concave or convex downwards, concave downwards, okay? So these are the shapes. Your graph will be below the x-axis. Here the graph is above. Can you see it's above the x-axis? Still the properties of the parabola function, the continuation. So now let's take a look at the parameter q. What does parameter q do on the graph? So the parameter q is responsible for the vertical movement. So it will either shift your graph upwards or downwards, depending on the given sign. So in this case, if your value of q is greater than 0 or is positive, then it means the graph will be shifted by q units upwards. So if your q is now less than 0 or negative, so it means the graph will be shifted downwards by the q units. And then the effect of parameter p on the graph. So parameter p is responsible for what? For the horizontal translation or the horizontal movement. So if the value of p is if the value of p is greater than 0, then the graph will be moved by 2 units to the left. So now you can see the difference between the two now. You need to be careful on this one. Take note of the following, because here we are saying our p is positive or is greater than 0, but now the graph will be moving what? Will be moved to the left. So if our p is now negative or less than 0, it means the graph will be moved to the right-hand side. So now let's take a look at the domain and range. Remember, in grade 10, we have learned that a domain refers to what? When we say a domain, we need to look at what? Specifically look at all the possible x values on our graph where the function is defined, or where the function can be defined. So the domain of a parabola function now, it means it will take what? X is an element of all real numbers, or x is an element of what? Negative infinity up to positive infinity. So always when you read a domain of a function, you need to read it from the left-hand side to the right-hand side, okay? So now let's take a look at the range. The range, when I'm talking of the range, I'm referring to what? All the possible y values from your graph now. Look at your graph, all the possible values of y where the function is defined still. So the range of a parabola function will be in this form depending on the value of what? Depending on parameter A. So if our parameter A is positive or greater than 0, so it means your range will be what? Y should be greater than or less than Q. Or you can either write it in this form. Y is an element of included, Q up to positive infinity excluded, okay? Or you can simply say if now your A is not greater than 0 but is less than 0, so it simply means that your Y is less than or equals to Q. Or you can also write it as Y is an element of negative infinity up to the positive infinity side. Remember, always when you read a domain, we need to read it from the left-hand side to the right-hand side. So when you read a range from the graph, you need to read it from the bottom going upwards, okay? So let's take a look at this example now. In example 1, you are given the function f at x is equal to negative 2x squared minus 4x plus 30, together with the g at x is equal to mx plus q. So as you can see this one, f at x, you can see that this is a quadratic function. So it's because it's in the standard form, ax squared plus bx plus c. So now, in example 1, we are required to do what? We are required to write down the y-intercept. This is our first example. Write down the y-intercept of the function f at x. Always, when you want to determine the y-intercept of a function, remember to let y be equals to 0. So when you let y be equals to 0, this is how it goes. For y-intercept, you let x be equals to 0, and then, so it means you're going to substitute throughout where there's 0, you're going to replace x by what? By 0. So when you substitute there, you finally get your x-intercept as, your y-intercept as, y is equals to what? F at x is equals to 30 or y is equals to 30. That is your y-intercept of your function of f at x. Okay? And then the x-intercept now. Determine the x-intercept of the function. So for you to determine the x-intercept of a function in general, you need to let y be equals to 0. If our y is equals to 0 now, it means where there is f at x, you're going to substitute with what? With 0. So when we substitute there, we get 0. We get a quadratic now equation. So then now, how do you simplify the quadratic equation? You can just take out the common factor of negative 2. When you take out the common factor of negative 2, you divide throughout by the negative 2 there. So negative 2 into negative 2x squared is x squared. So plus negative 2 into negative 4x is positive 2x. Negative 2 into positive 30 is negative 15, okay? So now from here, you can also divide both sides by this. You can just remove this negative 2 here by dividing both sides by negative 2. When you divide both sides by negative 2, so we're simply going to get 0 from here. On my left-hand side, I'm going to get 0. There is 0. And then here, I'm going to get x squared plus 2x minus 15. Then I can just easily factorize this. Remember, you can just use your quadratic formula, or you can use your calculator, or you can just use your trinomial factorization to get all the possible factors there. Remember, we have x and x using our trinomial factorization there. And then we also have what? The factors of 15 there, we have 5 and 3. So it's positive 5 and negative 3. So that one worked for us. Because when you multiply this, it's negative 3x. When you multiply positive 5 and x is positive 5x. When you add them together, they must give you the exact answer as the middle term here. So our middle term is positive. So then it means our factors is x plus 5 and x minus 3. Okay? Now, what are the possible x values now? Therefore, it means now at the end, you're going to have our x. Let's rectify this one. You're going to have our x as what? Therefore, it means our x is equal to negative 5, or our x is equal to positive 3. That's it. Okay? Moving to the next example now. We need to write the function of f in the form now, f at x is equal to a into x plus p all squared plus q. And hence, you need to write down the coordinates of the turning point from that, okay? Okay, from our given function, our function was in the standard form, negative 2x squared minus the first one. It was in the form of what? Negative 2x squared minus 4x plus 30. That was our original function. So now from here, remember always when you want to determine what, you want to complete the square. Because right now here, you need to write this equation in this form of a into x plus p plus all squared plus q. You need to determine what? You need to complete the square. So when you complete the square, remember to consider what? You need to make sure that the coefficient of what? Of a is 1 before you can complete the square. So check as to whether the coefficient of a is 1 or any other number. If the coefficient of a is not equals to what? It's not equals to positive 1, so it means now you need to take out the common factor. So now we need to take out the common factor now of what? Since our coefficient of a is negative 2, so we should take out the common factor of minus 2. So when you take out the common factor of minus 2, there we are, we have negative 2, and then we need to divide negative 2 into that. Negative 2 into that, negative 2x squared, we have x squared plus negative 2 into negative 4x is positive 2x. And then negative 2 into positive 30 is minus 15. Now, since it's in the standard form now, it's in this form, you can just complete the square. How do you complete the square? Okay, you write your coefficient of a as it is, negative 2 into, you're going to write your x squared plus 2x. Now, where did I get this positive 1 here? So in simple terms here, you're just going to add, you add, and at the same time you subtract half the coefficient of what? Of your x. So in this case, the coefficient of x here is what? Is positive 2. So if I say you're going to add half the coefficient of x and then you raise it all to the power 2, you're going to have 2 divided by 2. When you say 2 divided by 2, of course, you're going to have what? The half of, when you want the half of something, remember you divide by what? By 2. So you're going to have 2 divided by 2 all squared, so it's 1 all squared. So that's why I end up having what? Positive 1. So at the same time, you need to subtract that particular coefficient of x from your constant term. So our constant term here is negative 15. So we say plus 1 squared, and then at the same time, you need to say minus 1 squared. Remember, that's how we complete the square. So then you can simplify further from here. When you simplify, you're going to have negative 2 into x plus 1. Where did I get this x plus 1? So x plus 1 comes from the trinomial x squared plus 2x plus 1. So the trinomial x squared plus 2x plus 1 has the following factors. So the factors will be x and x, positive 1 and positive 1. So that's why we end up having what? X plus 1 all to the power 2. So when you simplify negative 15 and negative 1, then you simply get negative 16. So this is your equation in that form. However, it is not complete. You need to simplify it further. When you simplify it further, you multiply it throughout by what? By the parameter what? A, which is negative 2. So when I multiply it by that, I'm going to have negative 2 into x plus 1 all squared plus negative 2 multiplied by negative 16 is positive 32. So now this is my equation in the standard form, a into x plus p all squared plus q. Don't forget to take out the common factor of a in case the coefficient of your given function there is not equals to 1. Take out the common factor, and then you need to add and subtract at the same time half the coefficient of what? Of your x. Remember to raise it to the power 2. You square the coefficient, half the coefficient of x, and then you add and subtract at the same time. From there, you can simplify further, multiply it throughout by that particular parameter a, which is negative 2 in this case. Okay, now we are covered with this portion, but now they are saying hence write down the coordinates of the turning point. So it means now you're simply going to use what you have already written from the above statement or from the previous solution. From your workings here, you can just determine what the coordinates of your turning point. By looking at this function, which is in that standard form, you can see that, okay, the coordinates of the turning points, remember, will be what? Parameter what? P and parameter Q will serve as the coordinates of the turning point. So in this case, parameter P now is x plus 1. So if your parameter P there is x plus 1, it means now we are just going to say, so x plus 1 is equal to 0, and then x is equal to negative 1. So you can see that if your parameter P here is positive, so it means now your coordinate, your x coordinate of your turning point will be negative. So if your parameter is negative here, it's a negative value, so it means now your x coordinate will be what? Will be positive in that regard. However, with the coordinate or with the parameter Q now, Q is positive 32. So with the 32, the sign doesn't matter. It will always remain as it is. If it's positive 32, so the y value of your turning point will still be what? Will still be 32. So those are the coordinates of our turning point. Okay? Let's move to the next 1.4. We need to determine the equation of G passing through the points negative 2 and 6 and 0 and 10. So whenever you want to determine the equation, so by the way, our G was given us what? G at x from the previous one. G at x is equal to mx plus q. So as you can see, our G is a straight line. Since our G is a straight line, always when we determine the equation of a straight line, it's very much important for us to get what? The gradient. We need to have the gradient of our equation. We need to get the gradient. After the gradient, then we can just use what? The standard form, G at x is mx plus q. We need to determine what? We need to determine the value of q. So we can also use what? Y from your analytical geometry, y minus y1 is equal to m into x minus x1. You can also use this equation to determine what? That standard form to determine the equation of your straight line. So now we are given 2 points. Since we are given these 2 points, so it will be easy for us to determine what the gradient. So we need to start by determining the gradient of the function. So how do we determine the gradient of a function? Remember, for you to get the gradient, remember to use the small letter m, not the capital letter M, right? So for you to get the gradient, you need to say y2 minus y1 over x2 minus x1. So where do I get this y2 minus y1 and x2 minus x1? You just assign your points there. It's up to you. You can decide to say this is my x1, this is my y1, and then this is my x2 or y2. Or either way around, you can say x1, y1, x2, and y2. It's up to you. Now, in this case, what is my y2? Oh, my y2 is positive 10. You substitute with your positive 10 there. Positive 10, y2, then y1 is positive 6. So it's 10 minus 6 divided by x2, it's 0, then x1 is negative 2. So 0 minus negative 2 is positive 2. So when you simplify further here, you're going to get what? The gradient of positive 2. So our gradient is positive 2. Since we know the gradient, we can now determine what? The value of what? The constant term q. So for you to determine the value of what? Your q, remember, your standard form was g at x is mx plus q. So for you to determine what? To determine the constant term q, you just need to substitute these points. It's either you choose points negative 2 and 6 or 0 and 10, and substitute it into this given standard form of our straight line together with the gradient. You need to substitute all of them. Okay, when you substitute them, you substitute by that is 10 and 0. Okay, it means now in this case I used 0 and 10. My x is 0 and then my y is what? Is 10. So I'll substitute my x with 0 and y with what? With 10. So when I simplify further here, I can see that, okay, any number multiplied by 0 is 0. So it means my q is going to be what? Positive 10. So since my q is positive 10 now, it means my final equation of my straight line will be g at x is equal to the gradient 2x plus, and then my q will be what? Is going to be 10. So g at x is equal to 2x plus 10. This is the equation of what? Of the straight line passing through negative 2 and 6 together with what? 0 and 10. That is my equation of a straight line. Let's move to the next question. Now, we are required to sketch the graph of f and g on the same set of axes, and then we need to clearly show the intercepts with both axes as well as the coordinates of the turning point. Always when you determine the equation, let's recap on this. Always, when you want to determine what you want to sketch the graph now. You want to sketch the graph of f and g. Your f, this f is our parabola function, of which our g was our straight line function. And from our f at x already we have managed to determine what? To determine the x-intercept of our function. We are done with that. We need to determine the x-intercept by letting y be equals to 0. And then the y-intercept by making sure that we let x be equals to 0. And then we need to have what? The coordinates of the turning point. So depending on what your standard form of your given function, so you need to determine the turning point. And then from there, you are covered. You can also look at the shape of the graph. Check as to whether our a is greater than 0 or our a is less than 0 so that you can see the shape of the graph, whether the graph will be facing upwards or downwards, okay? Now, so, however, we already have those. We have covered all these x-intercepts and y-intercepts from the previous slides. Now, for g at x, we did not cover what? The portion of determining the x-intercept. So g at x is a straight line. We just need to determine the x-intercept. With a straight line, we don't have a turning point. You don't have to determine the turning point. So we have the x-intercept. You just let y be equals to 0. For the y-intercept, you need to let x be equals to 0. That's all. So now let's take a look at this. The graph of g at x is 2x plus 10. So now we want to determine the x-intercept first, or you can start with the y-intercept. It's up to you. So the x-intercept, we need to let y be equals to 0. So whenever you see g at x, then you can just substitute that with 0. So when you substitute, we get 0 is equal to 2x plus 10. Therefore, now when you transpose this negative 10 to the other side, it's going to be negative 10. Then we divide both sides by, we remove this 2 here, divide both sides by 2. We get what? X is equal to negative 5. So this is the x-intercept of the straight line. Now let's determine the y-intercept. The y-intercept, you need to let x be equals to 0. When we let our x be equals to 0 now, we can get the y-intercept as what? G at 0 is 2 times 0. Our y-intercept is what? Is 10. If you can take a look at this, our x-intercept of our straight line graph is negative 5 and 0. That's it. And then our y-intercept is positive 10. That is the x and the y-intercept of our straight line graph. So with the the parabola function, we have managed to determine the x-intercept. Okay, our x-intercept from the previous slide, it was negative 5, and the other x-intercept was positive 3. And the y-intercept was positive 30. So then our turning point from the previous slide, we've managed to calculate the turning point, which was negative 1 and positive 32. This was our turning point of the function. So, but remember now, your graph should have, at the end, these arrows at the end to show that this is a continuous graph. So that is our graph of our linear and the quadratic function. Don't forget to write down the signs or to draw the signs, these signs, to show that the graph ends from or starts from negative infinity up to positive infinity, okay? Now let's take a look at this. Let's look at activity number 1, which was extracted from the grade 12 mathematics paper, prelim exam 2015 from the Mpumalanga province. We have the question which was given in this format. You were given that g at x is equal to x minus 2, and the f at x is equal to y is equal to a into x plus p all squared plus q, whereby p 3 and 2 is the turning point of a and b are the x-intercepts of f, okay? D is the point of intersection of f and g. So this D is the point of intersection of the two graphs where the two graphs meet. So C is the y-intercept of the graph of what? The graph of G, of our straight line graph. So we are given that. So it's very much important to consider this. Take a look at the given information. Look for the implied information. So now, number one, we are required to determine the equation of the given function. So we are given a function which doesn't have an equation. So we need to determine the equation of the function in the form of a is equals to, or y is equals to a into x plus p all squared plus q. So when we determine this equation, we need to remember that, guys, remember, for you to determine the equation of a parabola function, is either you will be given two x-intercepts. So in simple terms here, there are three cases. We normally have three cases to determine what? The equation of a parabola function. At times, you will be given two x-intercepts of the function. So if you are only given two x-intercepts, case number one, so now you can say, you can use the standard form, y is equal to a into x minus r1 or x1 into x minus r2. Remember, r1 and r2 are the x-intercepts of your function, okay? So in case you are given two x-intercepts, you're just going to substitute that, r1 and r2 into that, and then look at the point, then x-intercepts, and from there you can determine the value of what? You can determine the value of what? The parameter a, then so that you can substitute at the end. So here we will be given two x-intercepts, then you can use the standard form, a into x minus r1 and x minus r2. So at times, they will give you a turning point together with what? One other point. So if you are given a turning point with one other point, then you can use the standard form, y is equal to a into x minus or plus p all squared plus q. You can use this standard form if you are given a turning point plus one other point. So in case now you are given y-intercept plus two other points. So if you're given y-intercept plus two other points, then you can just simply use the standard form, y is equal to ax squared plus bx plus c. Remember, c is the y-intercept. Now we'll be saving as the y-intercept of the function. But in this case now, somewhere you need to use what? You need to also infuse in the simultaneous. You need to use the simultaneous equation. You need to use the simultaneous. Simultaneous, don't forget, you need to use the simultaneous equation because you will be having two unknown variables when you substitute into that. Using your 2 points, your two given points, then you'll have to use the simultaneous equation. Now let's take a look at this one. Now in this case, you are given the equation now. They want us to write the equation in this form. Now let's check what are we given. We only given the turning point and this 1 point here, which is negative, the y-intercept. So it will be saving as one other point. So it's 0 and 16, negative 16. So we have a turning point and then one other point. So we can consider using what? Opting for option 2. We can consider that using that standard form, y is equal to a into x plus b all squared plus q. Now let's take a look at this. There is our given standard form, our given function in that standard form. So now we have the value of p and q. So the value of p and q serve as what? The turning point now, the turning point of the function. So our p is, if our p here is positive 3, it means our p is going to be negative. Then when you substitute, your p is negative 3. So our q is positive 2. So it means now here we're still going to have our q as positive 2. We're just going to substitute your p and q into the standard form. Y is equal to a into x plus p all squared plus q. We are not done. So we just have to make use of any point. As long as the point lies on the graph, on the given function, then you can just make use of the point. In this case, 0 and negative 16 lies on the function of f at x. Our x is 0 and then our y is negative 16. Then when you substitute, yes, negative 16 is equal to a into Our x is 0. Substitute our x with what? 0. So when you substitute with 0, that's what you get. 16 is equal to a into negative 3. Negative 3 squared is going to be positive 3 multiplied by that is positive. And negative 3 squared is going to be positive 9. So 9 multiplied by a is positive 9a. When you transpose this 2 now to the other side, it's going to be negative 2. So when you transpose, it's minus 16 minus 2 is going to be negative 18. Now when you divide both sides by positive 9, we get positive 9, we get our a as negative 2. So in this case now our a is negative 2. So if our a is negative 2, we can easily get the equation now of our function now. Our equation will finally be f at x is equal to, in the standard form, negative 2 into x minus, this 3 is the x-intercept of the turning point, all squared, plus, and then this 2 here is the parameter, what? Parameter q, the y value of our what? The y value of our turning point. Then we are done with the equation. This is our equation of our given function in the form of f at x is equal to. So now in this case, we have our f at x. You can just replace f at x with what? Y. Because we are required to determine it in the form of what? Y is equal to. So we will be saying y is equal to negative 2 into x minus 3, all squared, plus 2. Don't forget the 3 cases here. If you are given a 2x intercept, you just have to use the standard form, y is equal to a into x minus r1 and x minus r2 if you are given 2x intercept. But if you are given one turning point plus any other point, as long as the point lies on the graph, then still that qualifies. You can use the standard form, y is equal to a into x plus b all squared plus q. Now with 3, if you are given the y-intercept plus any other 2 points, now you can consider using the third case there, using the standard form, y is equal to ax squared plus bx plus c. But don't forget that c will be serving as what? As the y value of your graph, the y-intercept of your graph, okay? So now remember again, you need to use what? Under this case number 3, remember to use the simultaneous equation. So because somewhere you will be having 2 unknown variables when you substitute that, when you formulate or when you create 2 equations from that information, okay? Now, continuation of our example, we need to calculate the coordinates of A and D. What are the coordinates of A and D? So the coordinates of A and D, if you can look at the graph here, they are referring to the point of intersection. So that's where the 2 graphs are intersecting or where the 2 graphs meet. So in simple terms here, we are just going to equate the 2. So it means these 2 graphs are equal at point A and point D. So you just equate the 2 graphs together. When you equate them together, our f at x was given as negative 2 into x minus 3 all squared plus 2. You equate it to x minus 3. So when you simplify, we just get negative, okay? You remove the bracket, you expand the bracket and simplify. Apply the FOIL method. Then when you simplify, you get negative 2 into x squared minus 6x minus 9 plus 2 is equal to the straight line, which is x minus 2. We simplify. When you simplify further, you get negative 2x squared plus 11x minus 14 is equal to 0. Okay, you can just divide throughout by the negative there. When you divide by the negative sign, we get positive 2x squared minus 11x plus 14. Okay. Even if you divide throughout by what, you can just divide by, okay, no, it's not possible to divide by that. If you divide by a positive 2, you're going to get a fraction in the middle, and it's going to be complicated. You won't be able to factorize this easily. So now these are the factors of 2x squared minus 11x plus 14. So these are the factors. You can use your calculator, guys, or you can use your quadratic formula. Together with what, you can also use your trinomial factorization. So when we factorize this, we discover that the factors are x minus 2 and 2x minus 7. Remember, for you to test as to whether the factors are correct or incorrect, just make sure that the sum of x, when you multiply x together with negative 7, you get what? Negative 7x. So the sum of these two products now, the middle term, negative 2 multiplied by 2x is negative 2x. So when you add these two together, they must give you the middle term. So when you say negative 7x minus 2x is negative 7 minus what? Oh, this is negative 4x, so it's positive what? Negative 4x. Negative 7x minus 4x, negative 7x, negative 4x. When you add them together, they give you 7, negative 11x. So our factors are correct. So since we have the factors of the equation, we can easily solve for x. So our x will be x is equal to negative 2, or x is equal to positive 7 over 2. So we have our x-intercepts here, 2 and 7 over 2. But now we are looking for the specific the points now, the specific points of A and D. So between the two now you can decide which one can be qualified to be the x-intercept of A, which one can be qualified to be the x-intercept of what? Of the point D. Okay, between this 2 and the 7 over 2, of course, this 2 will come first. The 2 will be the x-intercept of what? 2 will be the x-intercept of point A. Okay, then point D, it's 7 over 2. So the x-intercept of point A is 2. Then the x-intercept of point D will be 7 over 2. All right? So for you to get the corresponding y values, you just have to substitute your x value here into any function. You can substitute this into f at x or into g at x for you to get the corresponding y value. So when you substitute this, let's just choose the straight line because this one it's going to be easy for us to determine the corresponding y value. So when you substitute this, is g at 2 is equals to 2 minus, is going to be 2 minus 2. So it means for point A, you are going to have 0 and 2 and 0. And then when you substitute that one with 7 over 2, when you substitute the 7 over 2 into g at 7 over 2, it's 7 over 2 minus 2. When you substitute that into the straight line, you can also substitute into your quadratic, but it's easier when you substitute into the straight line since it's in a standard form. It's easy for us to get the y value. So our y value will be 3 over 2. So we have the x value. If our x value is 2, then the corresponding y value is 0. Our x value is 7 over 2, then the corresponding y value is 3 over 2. Therefore, we are required to determine the coordinates, not the values only. We are not done, so we need to find the exact coordinates. Now, the points. The points will be A is 2 and 0, and the coordinates of what? Of D will be 7 over 2, together with what? 3 over 2. So we are done. We are covered with the point of intersection of the two functions. So these two functions intersect at these 2 points, point A and point D. Remember to equate the two functions together if you want to get the coordinates now of your points. Okay, now we need to determine the domain. Write down the domain of g at x. G at x now is our straight line. Indicate with the, okay, I forgot to indicate this arrow. So now for us to get the domain of the straight line, we need to read it from the left-hand side going to the right-hand side. So now we are looking for all the values, all the possible values of x in which the graph now is defined. So you can, as we can see this one, the graph is defined from the negative infinity part up to the positive infinity part throughout here. So that we have our domain as what? Our domain is x, an element of what? The graph takes all the real values, an element of all the real numbers. Or you can also write it in this interval form. X is an element of negative side. This is the negative infinity side up to the positive infinity side. So you have covered your domain of your graph of G. Now, with 4, now we are required to determine what? Write down the range of f. So for us to determine the range, we need the range of what? The graph of f at x, the parabola function now. When you read the range, you need to read it from the bottom going upwards. So when you read it from the bottom going upwards, looking at the graph, the possible values of y, or the possible y values where the graph is defined. So if you can read it from the bottom going upwards, this is the negative, it's the infinity side. So this is the negative y values. These are the negative y values going that side. So it means now our last value or our last part here is up to the infinity part. So when you read it from the negative infinity part, going upwards now, the range, our graph is defined here. The possible y values are defined here from negative infinity part up to, look at the y value now. Your y value, the corresponding turning point now, y value of your turning point is what? Is 2. So your range will be y is less than what? Y is less than, is between what? Y is an element of negative infinity up to positive 2. That's all. Or you can say y is less than what, or equals to negative 2. So we have covered the range. Okay. Now, number 5, we are required to write down the values of x for which now f at x is greater than g at x. In other words now, we need to have the graph now. Where is the graph of f? Above the graph of what? Of g at x. You also need to read this from your left-hand side, going that side to the right-hand side. So now from this graph, our f at x is the parabola function. So when you read it from left to right, if you can compare the two graphs, okay, don't forget to indicate the arrow here. If you can compare the two graphs from the negative infinity side up to this point here, you can say up to point A, the graph of f is below the graph of what? Of g. So this part doesn't qualify up to here. As you can see. So because here we are looking for what? We are looking for a portion, the possible x values where the graph of f is above the graph of what? Of g. So here the graph of f is below the graph of g. And then from point A up to point, let's compare, up to point D here. Point A up to point D, the graph of f, the parabola graph, is above the straight line. So now this one qualifies above straight line. So from point A up to point D, this part qualifies. So if you can check from point D now up to the positive infinity side, you can see that, okay, the straight line is above f at x, or our f at x is below the straight line g at x. So this part doesn't qualify. The only portion that qualifies is from point A up to point D. That's where the graph of what? The graph of f at x is above the graph of g at x. Okay? There is our solution. So our solution will be x is an element of what? Or x is between what? I cannot say between, but I will say, yes, I will say x is between what? Negative 2 up to, because this positive 2, sorry, is the x-intercept of our turning point, which is A there. There's a difference between between and from. So if you say x is between negative 2 and 7/2, do not include the equal signs, okay? You need not to include the equal signs. But then if you say your x is from 2 to positive 7/2, then that's where you can include the signs. The signs like this, you can say 2 is less than equals to x is less than equals to 7/2. So this is what? It's from 2 to positive 7/2. So this is between 2 and 7/2. Okay? Or you can also write it in an interval form to say x is an element of what? X is an element of positive 2 excluded up to positive 7/2 excluded. Now, 5.2, f at x multiplied by g at x is greater than or equals to 0. So now, where I multiply the y values of f together with the y values of g, now I must get any value which is equal to 0, or I must get any value which is positive. So now let's compare our graphs. Still we read from the left-hand side moving to the right-hand side. So our f at x is a parabola function. If you can compare from the negative infinity side up to point A here, my graph has the negative y values. The y values are negative. So looking at the straight line again, the y values are also negative. So when I multiply, so at this point A, these two products give me what? They give me 0 at point A. So now when I multiply these two, when I multiply this function together with that function, then the y values are now positive. This portion qualifies. Now let's take a look at the point from point A now to D. When I multiply now f at x, so the y values of my f at x from point A to D are positive, positive, and positive. So the y values of point A to D are now still positive and positive. So when I multiply the y values of the function f at x together with these y values, I still get a positive answer, okay? So from here, we also need to compare. We need to compare from here the positive y values, the graph of f at x here from this point D up to point B. The y values are positive. Same applies to this other graph. The y values are also positive. So when I multiply these y values of f together with the y values of G, I get a positive answer there. So it means now if you can look from this point B now, if you can look at these two graphs, f at x is a negative one. The y values are negative here. So if you can look at this graph of G at x, the y values from after point B now, the y values are positive here. So if I multiply these y values here, negative multiplied by positive, I'm going to get a negative solution. So now this portion will not qualify. So however, the portion that will qualify will be starting from this one, from this point B towards your right-hand side, your left-hand side. So this portion automatically fails. So what is this point B? What is the value of point B? Point B is the x-intercept, of the given function. So somewhere you have determined the x-intercept of your given function, and your x-intercept of a given function was determined to be what? It was determined to be, let's reverse a bit to check the equation. Okay, our function was negative, our f at x. Our f at x was negative 2 into x minus, x minus 3 all squared plus 2. This was the function of f at x. So since we are saying this b is the x-intercept of what? B is the x-intercept of the given parabola function. So for you to get the x-intercept of a parabola function, you need to let y be equals to 0. So when you let y be equals to 0, we are going to get 0 is equals to negative 2 into x minus 3 all squared plus 2. Okay, then when you transpose, you're going to get negative 2 is equals to negative 2, and x minus 3 all squared, you can just divide by negative 2, both sides. So you're going to end up getting positive 1 is equals to x minus 3 all squared. Okay? Then you need to apply the square both sides. Apply the square root on both sides. When you apply the square root on both sides, you get the square root of 1 here. It's 1, so it's plus minus 1. Plus or minus 1 is equals to x minus 3. So because here the aim was to remove the square, the 2 here, the exponent 2 here. That's why you squared both sides. And then plus or minus 1. So therefore it means now you're going to have this point as negative 1 is equals to x minus 3, or positive 1 is equals to x minus 3. So therefore it means you're going to have the points now. X minus, when you transpose this 3 to the other side, you're going to have positive 2, because it's negative to the other side, it's going to be positive 3. Positive 2 is equals to x, and then this one is going to be positive 4, because it's negative 3. When you transpose to this side, it's 3 plus 1 is 4. So 3 plus 1 is 4. Therefore, it means between these two x-intercepts, this 2 is the x-intercept of our turning point on point A. We have 2 and 0, and then the y-intercept of this point, of which this one we determined it when we calculate what? The points of intersection of that. Okay? And then we also have the x-intercept here of what? Of 4. So it means now the value of B has what? Has what? 4 and a 0. So our x-intercept here of B, so the point here is what? It's 4 and 0. All right. So now when you determine this, we need to write down what? Oh, we were supposed to calculate what? Okay, it's 4 and 0 and that. So back to our question here, we're just looking for the possible what? The x-intercept of point B. So the x-intercept of point B here is positive 4. So that's how we determine the x-intercept of point B. Now the x-intercept of point B is positive 4. So it means now the graph will give us the solution from the positive point B from negative to this side. So it means now we'll say x should be less than or equals to positive 4 for us to have what? To have the product of f at x times z at x being greater than 0 or equals to 0. Now let's look at the transformation now. Determine the transformation from f to p if p at x is equal to 2x squared. Now, from our original graph, we were given that the graph is negative 2 into x minus 3 all squared. F at x negative 2 into x minus 3 all squared plus 2. This is our original function. So now we need to compare the two. For us to end up obtaining this function, what happened to the original? If you can look at the original. So when you add the original, you can add, if you can add positive 3 here. If you can add positive 3 on our original function and subtract negative what? Subtract with 2. When you subtract 2, for us to obtain this function, if you can add with positive 3 and subtract with negative 2, we can get negative 2x squared, because now it's 3, negative 3 plus 3 is 0. So x minus 0 is just going to be x, then all squared is 2x squared. So now we have the point, now we have the new equation, p at x. So what happened to the original? For us to get that one, on the original, what did we do? On the original function, we moved the graph by 2 units downwards. This is our 2. By moving the graph by 2 units downwards, and also by moving the graph by 3 units again, horizontally to the left-hand side. Remember, if it's positive here, if you have added with positive, so it means now it will be to the left-hand side. So by moving it to the left-hand side, then it means we can get the equation p at x is negative 2x squared. So now, the remaining exercise now, this one you will do it during your spare time. You'll try this one, then these are the worked out solutions for the activity. And then you also have the worked out solutions for the activity. And then you are covered. Remember to use your past papers, use other additional materials, guys. That's all from me, and hope to see you again next time. Thank you.